So let's put to work all of the algebra properties and exponent properties that we just reviewed. So generally when you have instructions that say simplify in a math class, it's not so easy to know exactly when to stop. So simplifying generally means to combine any like terms if you can, to eliminate parentheses if you can, unless you're factoring. In that case, parentheses are good, and to not have any negative exponents. Okay, so like for example, in number 1, we have parentheses 4x cubed to the second power. Now, depending on what you're doing, this might be simplified enough. But we are going to want to like kind of access, this x to the third here is kind of trapped in the parentheses as well as the 4 too. So it's just an easier way to kind of write this. And so the first thing that you might notice here, you want to look back at the rules that you got or your exponent properties. And the only one that we have at the moment, the first and foremost one that applies, is that we have 4 times x cubed, and that's raised to a power. So here we have a product raised to a power. And if you look back, this was, this is basically this operation rule that we're going to be using here first. Okay, so to simplify this, really what we want to do is, we could notate this as, and I'm going to notate things. I don't have to write this out, but just so you can see where it's coming from, we're going to raise the 4 to the second power, and then we're also going to raise the x cubed to the second power. Right? Each of the things within the product here get raised to the second. Then we have 4 squared. Okay, well that's 16. And then here we have a variable raised to a power to a power. And that is yet another rule that we have here. In order to get rid of those parentheses, we're going to multiply those exponents together. Okay, so x cubed squared is the same as x to the 6th. And this is, I would say that's fully simplified. Nothing to do here to make this look any simpler. As I'm going through these examples throughout the whole semester, I would really recommend that whenever we start another one, like for example, we're going to start number 2 in just a second, you pause the video and you try to go through it on your own. Or even don't pause it, but try to go through, try to be actively participating in this process, for every example that we do. So here in number 2, we have 9x to the negative 7th times parentheses 3x squared, and all that is raised to the negative 3rd power. So there's a little bit more going on here. Let's look at, I see this in 2 separate pieces. So we have 9x to the negative 7th, and then we have this stuff in parentheses raised to the negative 3rd. Thinking ahead, we are going to want to combine the x to the negative 7th power with this x to the 2nd power. But we can't do that yet because this x squared is trapped inside of these parentheses here. So we're going to want to remove those parentheses first. And the way to do that is, just like in example 1, right? This thing here has the same kind of format as in example 1. And there are other ways that you can go about pretty much every math problem. So if you have a different route you take, but you end at the same place, that is, there's nothing wrong with that. So don't feel like the way that I'm going about it is the way that it has to be done. All right, so 9x to the negative 7th, that's just going to stay there. Okay, we have a product here with 3 and x squared. So I'm going to raise 3 to the negative 3rd, then we're going to raise x squared to the negative 3rd. Okay, now x squared is still inside those parentheses, so we're going to want to use that property right up here where we have a something raised to a power to another power and multiply those powers together. I'm just going to leave everything else the same for now, so this will be x to the negative 6th. Again, there are several options you can take at this point. I would recommend that we combine the x's together. And even though they're not right next to each other, multiplication, all this is multiplication here, and it's commutative. So you can move things around and put them next to each other. Okay, if you need to write that out, feel free, but we can combine the x to the negative 7th and the x to the negative 6th by adding their powers together. We'll deal with the numbers in just a second, so we'll just leave that as 9 times 3 to the negative 3. Then negative 7 plus negative 6 is negative 13. All right, now at this point, I would say we have negative exponents, and we might want to start thinking about getting rid of those by rewriting as a fraction. So since we have multiplication across these three things here, we can change this multiply and this multiply to divide if we bring the 3 to the negative 3 and the x to the negative 13th down into the denominator. However, the 9 has to stay into the numerator. 3 to the negative 3 becomes 3 to the positive 3, and x to the negative 13th becomes x to the positive 13th. All right, we have no negative exponents. We've got x to, just a single x raised to a power. Now 9 and 3 cubed have something in common, so we might be able to simplify that. So 9 cubed is 27. Okay, then 9 goes into 27 actually evenly, so we can cancel the 9. We'll have a 1, and 27 divided by 9 is 3. So the very last way we can simplify this is by canceling those or dividing those. In the end, we'll have 1 over 3 times x to the positive 13th. Again, just looking where we started here and where we ended. Where we ended is a lot more, more simplified than where we started. All right, let's look at example number 3. Again, I encourage you to pause the video and work on this before and see what you might do. All right, this is 2 square root of x all over negative x squared. When you're working with things with x's in multiple places and we have a root or a radical form, I would always suggest that you get that out of radical form and put it in exponent form. Okay, so just in the last video, we reviewed how that works. So if we have, here's the rule, it's the rth root of x is x to the 1 over r. So the square root of x will be x to the 1 over 2. All right, now the reason we wanted to do this is because now we have an x to a power up here and x to a power down here, and they're divided. So we can use the property where we subtract their exponents. All right, now we have times here, 2 times. We have basically a negative 1 times. So we can sort of divide numerical parts and then divide variable parts separately. So I would say, we can have 2 divided by negative 1. So that's negative 2. Just get rid of our fraction here. Then we have x to the 1/2 minus 2 in the exponent. Now this is a calculator class, so you can use your calculator to figure this out if you need to. It's not that bad. Even if you don't have one, you can piece this together. So 1/2, right, minus 2. 2 is 4 halves. And so here's our common denominator. When we subtract them, we'll get negative 3 halves. Okay, so this is negative 2x to the negative 3 halves. Now we have it almost fully simplified, except we don't want to leave our answers most of the time with negative exponents. It's kind of hard to understand what that means. So I would convert this now into a fraction. So it's not really any simplifying anymore, it's just kind of rewriting. Okay, now the negative 2 here doesn't have a negative exponent on it, so that's going to just keep hanging out in the numerator. And then the x to the negative 3 halves can move to the denominator, and its exponent becomes positive 3 halves. And this is about it. Optionally, you could rewrite that x to the positive 3 halves as in radical form. So if you want, you could say, okay, this is negative 2 over. All right, it's power over root, so it's to the 3rd power, and it's the square root. So square root of x cubed. Generally, that's not as important as rewriting as a fraction without negative powers, but if you like the radical form, then by all means, you can definitely write it that way. Okay, moving on to example number 4. As I said in a couple times already, there are several different ways usually that you can go about a math problem, especially simplifying. What I'm going to do is go through one way of simplifying this. But again, if you have another route that you took and it got you to the same place and you understand that, there's nothing wrong with that. No matter what route you take though, just gonna kind of zoom in here so we have a little more space. No matter what route you take, you definitely want to deal with this first. Okay, come on, why aren't you? Sometimes this gets a little bit laggy and I am not sure why, so I'm trying to indicate to you, oh, are we almost there? Let me try to write on here and see if it, yeah, okay, here we go. So I'm trying to show you, right, this radical form here, this fourth root of y cubed is something that we probably wanna get rid of. So let's first, we're gonna leave everything else the same. We're gonna rewrite that fourth root of y cubed as y to the, and its power over root, so y to the 3/4. My iPad is having a Monday. I don't know what's going on with it. Oh, come on. Okay, there we go. Now again, here's where I could see several different things. One thing that you might consider doing is combining these y's first by subtracting their powers. Another thing that you could do is we have a quotient, something divided to an exponent to the fifth. And so we can, get rid of these parentheses by raising the numerator to the fifth and raising the denominator to the fifth. Those are two different things that would get you, again, the same spot. So what I'm going to suggest we do is maybe first, I'm just going to simplify by, I don't want two y's here. I'm just going to make it into one y. So let's say we still have 2 divided by 3. So we'll leave that 2 over 3. And then y squared divided by y to the 3/4. Okay, we're going to subtract the powers. So let's see, 2 minus 3/4. Okay, 2 is how many fourths? 8/4, I think. So 8/4 minus 3/4. That gives us a common denominator. We subtract the numerator, so that's 5/4. So this will be y to the 5/4. Okay, so now what we have here is something 2/3. I know it's a fraction, don't let it freak you out. But we have a number of times and then y to a power. So we have a product in here raised to something, raised to the fifth. So we've got to do, okay, 2/3 to the fifth times y to the 5/4 to the fifth. Okay, we're just going to raise each parts of the product to the fifth power. All right, then let's see, 2/3 to the fifth power. I could rewrite that as 2 to the fifth over 3 to the fifth. Now y to the 5/4 to the fifth power, what we're going to do to remove those parentheses is multiply the exponents. So 5/4 times 5. Okay, when we're multiplying a fraction by something, we can always kind of think of the whole number as being over 1. And then when we multiply fractions, we just multiply across their numerators and then multiply across their denominators. So 5 times 5 is 25 and 4 times 1 is 4. So this will be not the best exponent in the world, but it's okay. Y to the 25/4 power. And the very last thing, I don't know, 2 to the fifth, I think that's something we could probably just rewrite as a number that's easier to understand. I believe that's 32. And 3 to the fifth, let's see, that is 243. And so here is our more simplified form than what we started with.